Today, we're looking at lesson 1.5. Specifically, we're looking at how can we factor a polynomial function. That's what we're going to spend most of the time doing. Now, the point of factoring is here, is it can identify key characteristics when we factor. So factoring is what identifies those key characteristics. Last class, we identified key characteristics using technology. Okay, so we learned that last class, and we'll verify with technology. But today, we're learn how to factor. And the why is so we can do key characteristics using algebra, if you will. So that's the point today of what we're doing. So first off, when you talk about a factor, what is a factor? A factor is anything that multiplies. What is a factor?
Anything that multiplies.
Very good. So right now, if I wrote out 7 times x plus 2, and I asked you what form is this in, you would respond with, this is in factor form. Why is this in factor form? They're multiplying. If I wrote it out like this, guess what form this is? Factor form. Why is that factor form? Multiplying. Now, what they call something that's not multiplying, they would call this standard form. In standard form, there are some key information we get. That would be the y-intercept. But other than that, there's not much. You could tell it would be a parabola, but there's not much key information we get from this. From factored form, I could tell you this is going to cross the x-axis at -1 and -2. I can tell you that right now because I know that these will be my zeros and the x's are liars. Have you heard me say that already this school year? X's are liars. So though it says x plus 1, that means it's actually going to cross the x-axis at +1 or -1. If you see a +1, it means it's going to actually hit at -1. If you see a x plus 2, it's actually going to cross the x-axis at -2. That's the point of a factor. Now there's other names they could use. They could say root, zero, solution, x-intercept. Today we're going to be saying factor. Okay, so that's just a general overview of what we're kind of writing out. This right here is called factored form. That's factored form. And this over here is what they would call standard form. Standard form is what you've seen most of your other math classes. And up to this day in this lesson, in this class, you've seen standard form. So today we're going to find out how to get to factored form. Okay, so first, using just a picture that's shown here, look at this graph here. Does this graph have any zeros?
Yeah.
Yes, it has 2 zeros. Now, what x values would you say this 0 is at right there? What's the value on the x-axis? 2. And what about over here? -2. Okay, what that means, if you wanted to create that as a factor, to have a factor of x minus 2, it comes from the parentheses. Well, let me show you how it gets there. If that's where x equals -2, it comes from the parentheses x plus 2. Now this one, and I would highly encourage you to write this part down. If this is when the x-axis is 2, that's when the x value equals 2. It comes from the factor x minus 2. So that, based off of that information right there, I could determine the equation would look like this. My equation in factored form, I would put these two together. Factors, remember, they mean multiply. I would have these two parentheses multiplying each other, and thus I'd get the factored form. This is the factored form because we have the factors. This is the factored form. That would be my equation that would give me this graph. Now, from the previous slide, all the different words you could hear teachers say. You could say -2 and 2 are roots. You could say these are zeros. That's the words I used to start the problem. I said, where are my zeros? You could call them solutions. You could say they're x-intercepts. And finally, what we're going to be saying today is x minus 2 and x plus 2 are factors. All of these are the same, mean one and the same thing. It's just different ways you can say it. Okay, so that's a visual to show you what we're going through today. I'm going to be walking you through the process of how do we do it without a calculator for most of the lesson. So let's begin here. This function here, when you look at this graph and you look at the equation below it, what is the degree? That means highest power again. What's the degree? 6. If you have a power of 6, that means you can have at most 6 zeros. And if you have at most 6 zeros, you have at most 6 factors. Because again, a zero and a factor can be interchanged. That terminology is the same. So if you have at most 6 zeros, you have at most 6 factors. That's what this is telling you right here. And this relative extrema, that means maximums and minimums. Here in this word extrema, this means maximums. That's not how you spell that. Maxim. Oh yeah, it is. Maximums and minimums. Maximums and minimums. That's what extrema means. That word extrema, it means maximums and minimums together. So what does n minus 1 mean? If you have at most 6 zeros, you can have at most 5 maximums and minimums. It's always one less. If you have at most 6 zeros, you have at most 5 maximums and minimums. And why is that? To get a second zero, you have to turn. A turn in the graph is what's going to become a maximum or minimum. It's when a graph turns from decreasing to increasing, you have a minimum. A maximum occurs when you turn from increasing to decreasing. So that's why it's always one less. To get to a second zero, the graph has to turn. Now this graph in particular, how many zeros does it actually have? 3 zeros, which means we'd only have 3 factors. It was just we're going to learn that some of the factors have a power attached to them. Okay, so now let's start through this first problem here. Example 1. On example 1, what is our degree? Okay, since our degree is 3, we're going to say at most 3 zeros and factors. I'm going to write zeros and factors until we get down the terminology. So I'm going to say zeros and factors. Now, however many we have, it'll be the same number, same amount of zeros and the same amount of factors written out when we write them out. So it says determine all the real zeros by factoring. Okay, so here's the first thing we're going to do. We're going to first do GCF. Do y'all remember what GCF stood for? We did this on the very first day of school when I did the introduction. I reviewed you on GCF. Do you remember what that stands for? Greatest common factor. So you look, is there anything common in these 3 terms up here? Here, X. I totally agree. The first thing I'm going to do is divide out an X. Now, everything in math has an opposite. Everything in math has an opposite. The opposite of GCF is distribution. What's a distribution? It's when you multiply through when you distribute. What are you doing? You're multiplying through a parentheses. This is the opposite, which means we're going to create a parenthesis with something at the front that could multiply through it. Okay, what is shared all the way across this equation? Did you already tell me? X. That's what goes in front of the parentheses. Now, in the parentheses, you put what's left if you divide it out in X. Again, I'm doing the opposite of distributing. So I'm not multiplying, I'm actually dividing. If I divided X cubed by X, what would you get? If I took X cubed and you divided out in X, what are you left with? X squared. That's your first term inside the parentheses. Now I have a plus. Now what if I took 5x squared and I divided out an X? What would I be left with? 5x. So 5x comes next. And now plus, what's 4x divided by x? 4. I started right at 4 there. You're correct. 4. Okay, so this is exactly the opposite. GCF is exactly the opposite of distributing. Instead of multiplying through a parentheses, we divided out an x and created a parenthesis. You see how it looks exactly like yours? You should be doing a distribution at this point. That's because we did the exact opposite. Okay, that's the first thing we're going to do. The second way we're going to factor is what's called X method. X method. Now here's how X method works. We are going to take the factors of this quadratic here, and I'm going to label these letters. I'm going to put A above the x squared. I'm I'm gonna put a B above the 5 and a C above the positive 4. Now, how X method works is like this. We're gonna draw an X. And we're gonna put whatever mathematical value we get of multiplying A times C in the top, and we're gonna put a B on the bottom. We're gonna find two numbers. And I'm gonna just put M and N here. We're gonna find two values where M times N equals A times C, and where M plus N equals B. Now this is our process right here. I'll call this the process. That's the process what we're doing there. Now, right now you're going, wait, what is all this? Let me show you with numbers, and it'll probably be a lot easier to catch on. Okay, so here, what is our, in this problem, what is our A value if there's no number? A refers to the coefficient of x squared. How many x squares do I have if there's no number there? So it's 1 times 4. What is 1 times 4? Put 4 at the top of your x. Now B goes down below. It's the number of just x's, plain old x's. How many x's do I have? What's my coefficient? 5. That goes there. What we're looking for are two numbers. We're going to call them M and N that multiply to be 4 but add to be 5. So the way I do it is I always do multiplication first because it'll limit your options real quick. What are the only numbers that can multiply to be 4? Whole numbers. 4 times 1, and there's another one. 2 times 2. 4 times 1 and 2 times 2. Which one, when you add, gives you 5? Those are our two numbers. Here, we're going to do 4 and a 1, because 4 times 1 is 4. 4 plus 1 is 5. Does that make sense? Okay, so how does that factor work? What you do is you split your power of the quadratic. You split your A terms power. So I still have this x out front, but I split this A term power, and we're going to have two parentheses. You see I have two parentheses written out now? Not just one parenthesis. I've written it now as two parentheses. You split this term's power. If you split a power of 2 in half, how many are you left with? 1. So it's going to have 1 power of x on each. You would write down the number A if it was any number other than 1 first. This one doesn't have it. And then you include these numbers. So that's a positive 4 and a positive 1. So plus 4 and plus 1. That's right there, the factored form. We now have our factored form. That's the factored form. This up here was the standard form. I'm going to go ahead and put that in there. That's the standard form. So what does this do for us? It tells us what our zeros are. I can tell you we have 3 zeros. How do I know there's 3 zeros? Because I have 3 factors. What is a factor again? We said at the beginning of the class, I gave you a definition. What is a factor? Anything that multiplies. How many different items do you see multiplying? 3. This x, this parenthesis, and this parenthesis. 3 items multiplying means I have 3 factors. If I have 3 factors, how many zeros do I have? 3. The zeros occur anywhere. You just make your numbers be liars. So this x is all by itself. That means it's x equals 0. That one's x equals 0. Because it's all alone. There's no number. There's no addition or subtraction to change it. Okay, what about here? Remember, x's are liars. So it says x plus 4. So what does that mean x actually equals? -4. And finally, where it says plus 1, it's going to become -1. That is our solution here. I'm going to go ahead and put the factored form in it. We'll go ahead and include all that. Now you don't have to graph it. I'm just going to show you real quick. I'm going to type in this equation, and I'll type it in standard form. Again, I mean, I'm going to start with the original problem. Make sure we didn't make any mistakes along the way. And you're going to see what I told you is true. If I graphed x cubed plus 5x squared plus 4x, and I hit enter, you're going to see this graph has 3 zeros. Does it have 3 zeros? Let me move it over here. It'll be a little bit bigger. Does this graph have 3 zeros? Yeah. Where do they occur at? What's this one? 0. What about this one? -1. If this is -1, that's -2, -3, and -4. Is that what we said the answer should be? You bet it is. So it had the zeros just where we said. That's at -4. This one's at -1, and this one's at 0. How about that? We did it without a calculator. Okay, let's reload and try it again, because I know this takes a little bit of practice. This time, tell me, what's the degree of this function? What does that mean if your degree is 4? At most, doesn't mean it has to have all of them. 4 zeros. And not only zeros, but if it's a 0, then it would also be called a factor. At most 4 zeros and factors. All right, what was our first step that we did last time? GCF. You look for something common. Anything shared? Do you see anything shared between those three terms? An x to the 4th, -13x squared, and a positive 36. Do you see anything common? This doesn't have a coefficient that can be divided out. This does not have an x. There's none. So do n/a, not applicable. There is nothing to be divided out. So once you do step 1, we go into step 2. What was step 2? Okay, so let's go ahead and label this. Now I'm going to rewrite the equation. So we have x to the 4th minus 13x squared plus 36. I'm going to go ahead and do this, a times c, and I'll put b in the bottom. And we're going to find our two numbers m and n in a second. This is my a, that's my b, that's my c. What do I put for a if there is no coefficient?
1.
So it's 1 times 36. What is 1 times 36? Good. Now b is -13. We'll get to the negatives in a moment. I do negatives last. What I'm going to do is ask ourselves what numbers, I should say, can multiply to give us 36. If you do the multiplications first, this number is a whole lot easier to come up with second. What things could even multiply to give you 36? Okay, and here's a pattern. If it's a bigger number, I just start with 1. Can 1 multiply to 36? Yes. 1 times 36. Can 2 go into 36?
Yeah.
Yep. There's 1 in 36. What else is there? 2 times what? 18. Okay. Can 3 go into 36? How many times? 12. Can 4 go into 36? 9. Can 5 go into 36? Can 6 go into 36? You can stop once your numbers get equal because you've already listed it out. Everything else will just be a duplicate of what we already have. So it's going to be one of those answers. So now what you ask yourself, it's which one of these could add or subtract to get you a 13. Add or subtract to get you to a 13. Again, I'm not even going to consider the negative yet. 4 and 9. These are the only ones that can get us to a 13, 4 and 9. So those are going to be our two numbers. So now I write in the 4 and the 9. Is everybody tracking with how I did that so far? Now, what would make them add to be a -13? What combination of negatives? One negative, this one negative, or both of them negative? Both negative. Now check it. Is -4 times a -9 positive 36? So we did it right. Okay, great. So this one, what you do is you rewrite it out. Do you remember what I said you do? We're going to write 2 parentheses instead of, well, that one did not have a parentheses. So I'll write 2 parentheses. Do you remember what you do with the a terms power?
It's just that.
No, last time it's a word that starts with an S and rhymes with blit. You split it. So if it was a 4th power, what does it split to become? X squared. Put an x squared there and an x squared here. This is a -4. This is a -9. Now, is this in factored form where they're multiplying with each other?
Yes.
Yes, it is. That is factored form, but you can actually factor it further. You know why, how I know that? Because when I look at these x's, you see how they have a squared power? I could do this all over again. So this one, I can do this again. Since I still have x squared, since x squared still exists, we can x factor again. Okay, so here we go again. I'm going to draw two x's. Why do you think I'm drawing two x's this time? Because I have this x squared and this x squared. Okay, so this is one you haven't seen before. This time, here's my a. I don't have a b. This is a c. You see how it's missing a b? There's nothing with a single x. So we do b equals 0 on this one. So what is 1 times -4? -4 goes there. B is 0. I'll pick up in a second, but let's start with what are the numbers that can multiply. Again, don't do the negatives till the end. It just confuses you. What are the numbers that can multiply to be 4? 2 times 2, and what's the other one? And 1 times 4. Now, which one of them could add and subtract to give you a 0? 2 and 2. These are going to be our two numbers. So we're going to use 2 and a 2. Now, what makes them add to be a 0? One negative, both negative, or no negatives? One negative. 2 minus 2. Those are going to be my two numbers. Cool with that? Let's reload and see it one more time. Over here, what am I missing? I only see two terms.
B.
Your B. So B is 0. Whoops, I meant to go to a color I haven't used. Let me try this again. How about orange? What is my A if it doesn't show a number? And my C is -9. So here we go. A times C, that's 1 times -9. And then B is 0. Okay, what are the only numbers that can multiply to give us 9? Again, ignore the negative for a moment.
3 times 3.
1 times 9 and
3 times 3.
3 times 3. Now you need them to combine to be a 0. So which could add and subtract to give you a 0 somehow? 3 times 3. So it's 3 and 3 here. Now how do I make it a 0? One negative, both negatives, or no negatives? One negative. I should be pointing at this one. I think it looks better to put the, if you have one negative, do it at the end. 3 minus 3 is 0. 3 times -3 is -9. So what does this mean? How can I rewrite my answer? My final answer would be written this way. I'm now rewriting this. I'm splitting this power. So what's a split of a power of a 2? Okay, so the first x method is going to give me 2 parentheses. Let me rewrite this underneath so I have more space. I'm going to have a total of 4 parentheses. This x method is going to give me 2 parentheses. And this x method is going to give me 2 parentheses. So I now will have 4 parentheses. When I split this x squared, each one gives me an x and an x. And then I plug in these numbers, a +2 and a -2. +2 and a -2. And then I split this x squared, and again I get x to the first power with a +3 and a -3. So how many factors do you now count? 4. So how many zeros do I have if I have 4 factors? 4 zeros. And now your x's are liars. So if it says x + 2, what 0 is that? This says x - 2. This says +3. This says -3. That's going to be our solution there. Got to scroll up a little bit to see the whole original equation. It was a 4th power, a 4th power, a -13x squared, and then a +36. Oh, +36. There's my picture. We check the picture. How many zeros do you see on this picture here? It is 4 pictures. I gotta shrink it so I don't cover up our work. That is 4 zeros. My zeros, they occur at, that's -1. So what's this? -2. What's this one then? -3. That's +1. So what's this one? +2. And then, did we get it right? You bet we did. That'd be the graph. Go ahead. All right. You've seen me do it twice. I don't expect you just to have it mastered yet. Nevertheless, I want you to try one. Okay, so first, part A. I want you to write down how many, I want you to write down the degree and then the possible number of zeros and factors. Do that first. I want you to write your degree and the possible number of zeros/factors. And then secondly, I want you to factor. Will this one have a GCF? Is anything shared in this problem? Not only x to the first power, but this time they all have a minimum of how many powers? They all have at least how many powers? 2. So you're gonna factor out an x squared to the front. Now you don't have to do an x method when you have a GCF factored up front. You don't have to do an x method on the GCF. You only do the x method on what's not the GCF. So what I'm saying is, once you pull out the x squared, you don't touch x squared again. That'll just be x = 0 at the end. So you only x method the stuff that's not the GCF. All right, go ahead. All right, now I'm going to show you how we can kind of do this backwards. The last few problems, we've started with the algebra and then we've gone to the graph. This time on example 3, I'm going to show you how you can use your graph to give you an equation now. So open up your calculators with me. Go home screen, new document, don't save. Add a graph, and let's type in this equation. X cubed minus 3x squared minus 6x plus 8. Now, after you graph, this is one we should not zoom fit. Absolutely should not zoom fit. Can anybody remember why we don't use zoom fit here? Was there a restriction here? Is there a restriction on this? Remember how we did restrictions last class? Did it restrict it? No, let me show you what happens if I do a zoom fit. If I do a zoom fit without restricting my equation, and the graph looks like this. Now that's a bad looking graph. Why is it a bad looking graph? Because what you would need to use, what in the world just happened? I don't know what I just did there. Let me take that off. I don't know what I did there. I go menu, zoom, standard. Let me try to see if I can reset it. My graph is all screwed up. Look, I have like 2 boxes. You see that? There we go. What I'm going to do is, sorry about that. Now that I'm back, what I'm going to do, if you don't have a restriction, I'm just going to click on the axis to change them. I need to get a little bit taller. You see how it cuts off the top of the graph? My guess is it looks like it's coming together. My guess is if I change this number up here, the 6.67 to a 20, I'll be able to see the top of the graph. Can we see the maximum, that local maximum, when I change it to a 20? Yeah, and I'm going to change this -6.7 to a -20, and now I can see the whole graph. Okay, now that I've done that, that's the picture I'm using. I just clicked on the y-axis values to do that. I did my own version of zoom fit. I guessed 20 and -20. I just took a guess. Could there have been a better number? Sure, but 20 works just fine. Okay, so looking at this picture, where do you see the zeros? Now that's negative 10 there. This is positive 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's counting by 10s. What number is that? That's a negative 2. What number is this? Oh, I didn't realize it showed me there it's counting by ones. If that's a 1, then this is 2, 3, and 4. Y'all want to take a guess how we could rewrite this equation in factored form? What would give me the 0 x equals negative 2? X plus 2. Very good. What could give me the 0 at positive 1? X minus 1. That's because x's are liars. And what could give me the 0 at positive 4? X minus 4. That's going to be my answer right there. Now remember, all this is because what? X is? That's what we say. X values are liars. Now take a look. Or if I ask you at the start, what's the degree of this problem? 3. So how many zeros could we potentially have? 3 zeros. Is that what we had?
Yes.
Yeah. And you could look and you could tell if I just multiplied all this out, we would get the original. Just check it out. Let's only multiply the numbers this time. If we only multiply the numbers, what would you get? What's a positive 2 times a negative 1? Negative 2. And then you multiply that times a negative 4. What would you get? Positive 8. That's where the 8 comes from. Now, where would the x cubed come from? Only multiplying the x's. What's an x times an x times an x? X cubed. These other two middle terms would be by multiplying, for example, x times negative 4, x times negative 1 times x times negative 1 times negative 4, and all the combination in between of some x's and some numbers. That's how you get the middle two terms. All right. So any questions on how to do that by graphing? That one should be pretty simple. Hey, what do you call this point right there? What's the name of that point? A local maximum, because it's not an absolute, but it is a max. What do you call this one? Local minimum. This is what you'd call extrema. How many extrema, that means maximums plus minimums, does this graph have? 2. Remember, it's always one less than the 0. The number of extrema at most extrema is equal to 1 less the most zeros. So how many zeros did this have? 3, which is the most it could have. The most extrema it could have is 2. It's always 1 less. The reason why, the only way to get a second 0 is you have to turn. It's a turn on the graph that creates a maximum or minimum. This graph changed directions. It was increasing, now it is decreasing. Therefore, we had a maximum. Now that we've hit a second 0, to get to a third 0, what's the only way to get to a third 0? So we have to turn this graph around. We are decreasing. What has to happen to it? Increase. That's so 2 extrema. All right, let's go to example 4. There's one more way we can factor in my class, and this is what we'll do if it's more than 3 terms. I cannot do X method on 4A. Can't do X method. Why can I not do X method? How many terms do you see? 4. X method works if it's 3 terms. You have an A, a B, and a C. Does this have an A, B, and a C? Well, if you want to call it A, B, and C, it also has a D. You can't do it if it has a D. So what do? We use what's called synthetic. So synthetic, some of you might have learned in your algebra 2, but a lot of you probably did not. The first step to synthetic. Let me write this out. I'm going to type this in. Step 1 is you'll solve the divisor for X. Okay, so as I type this in, I don't want to take up too much space, so I'm going to change this where it's a little bit smaller. So we're going to solve for the divisor. I'm going to type it in so you can, I want to make sure you can read it better. So instead of writing all this in, I'll type it in. Solve the divisor for X. So that means the part that's doing the dividing. In this problem, what's doing the divide, this is the right here, the divisor. So what we do is we solve for X. What does that mean? You take 2x minus 3 and you set it equal to 0. This is going to take, it's going to create what the lie is, or take away the lie, if you will. So if you were to solve that, what would you do? You see 2x minus 3 equals 0. I'm solving this. How do I get rid of a negative 3? Positive 3. I do the opposite. That's why there's a liar. That's why we call it the liar, because you have to solve it and it changes all the symbols. So now I have 2x equals 0 plus 3 is 3. Okay, that 2 is multiplying. Right now it says multiply by 2. Well, that's going to be a liar because x is a liar. So what's the lie of multiplying? What's the opposite of multiplying? Dividing. This is what we're actually going to divide by. Instead of multiplying by 2, we're actually dividing by 2. And so what do we find out x actually equals? 3 over 2. So that's what we did here. X equals 3 over 2. That's our step 1. So what's step 2? Step 2 is we are going to write out the coefficients. Write out coefficients. Okay, so what do I mean by that? What we're going to do is we're going to divide. We're going to say x equals 3 halves. And I'm going to write out my coefficients going across. I have a 2x to the cubed. Coefficients are just the numbers in front. I have 2x cubes minus 1x squared minus a 7x plus 6. Everybody tracking? Step 3, we're going to drop the first term and follow what I call mama. We drop the first term and we follow mama. So let me write that in. And I'll do it right down here. Drop the first term and follow mama. Now you might be thinking, what is mama? Well, if you had Miss Lester, you know. Does anybody have Miss Lester? You remember what that stood for? Nobody? It means multiply, add, multiply, add. We just do that all the way down. So I start with multiplying. What you do is you take the 2 and you multiply it times 3 halves. Now this is a fraction, so how does it work? Fraction means multiply the top number, you divide the bottom number. What's 3 times 2? 6. Then you divide by 2, what do we get? 3. That goes there. That was the multiplying. So now that I multiplied, I add. What's negative 1 plus 3? I'll put a plus there so you can see it. Negative 1 plus 3 becomes 2. You're absolutely right. Now I multiply again. So we already just did this number, but I'll do it again. What's 3 times 2? Again, with a fraction, you multiply the top. 3 times 2? 6. You divide by 2. 3. That goes there. Again, it's a positive 3, so I'll put a plus because now we're on adding. What's a negative 7 plus 3? Okay, good. Now we get to practice again. New number. So now that I added, I can go back to multiplying. So you just keep doing multiply, add, that pattern. So negative 4 times 3. Again, you multiply the numerator. What's negative 4 times the 3? Negative 12. Divide by 2. You put negative 6 there. So now we add. What's a positive 6 minus a 6? 0. That right there is what we call a remainder. And if your remainder is 0, that means it's a factor, and this is a 0. This right here is a factor. So this is, if you have a 0 for a remainder, therefore, that means because this is a 0, x equals 3 halves is a factor. Or I'll say is a 0 because that's not a factored form. And the 2x minus 3 is a factor. Okay, we're not quite done yet. We have one more step here. If the divisor is a fraction, divide the quotient by the denominator. There we go. Now, so what do I mean? Look at your divisor. Was my divisor?
2x.
Was my divisor a fraction? Yes, my divisor was a fraction. I'm putting this in so you can look back later and see, figure out what steps what. Okay, so since this is a fraction, what you do last step 4 here is I want to come in and I'm going to divide all this by the denominator. What's my denominator of my divisor? 2. Everything gets divided by 2 except the remainder. You'll never touch the remainder. So what happens is since this began as x to the 3rd power, whenever you drop a power. So this was 2x cubed, it now becomes x squared. This was an x squared, it now becomes a x, and this it was an x, now it has no power at all. So here's what it means my value is, that this becomes, I have the factor 2x minus 3 up front. I put this in. I have, what's 2 divided by 2?
1.
So I have 1x squared. This becomes a positive because there's no negative symbol, plus an x minus 4 divided by 2 is negative 2. That's how that would factor. Now, we can actually X method this to go one step further. So now that I've done all of that, I could come in and say I could X method this. So if we want to do an X method here, let me write it out here, X method. We can do an X method or an X factor, whatever you want to call it on this part. I'll draw an X. It'll be A times C, B in the bottom. A, B, C. My A value is a 1. What is 1 times negative 2? Negative 2. My B value is also a 1. What are the only, don't pay attention to the negatives till the very end. What are my only values that can multiply to be 2? And what are the only numbers that multiply to be a 2? 1 times 2. Kyron, you need to have your phone up. It's got to be a 1 and a 2. Has to be. I'm going to do a 2 first because it's going to make more sense in a moment. Now, to get to the value 1, now is when you take in the negative into account. To make this become a 1, do I have a negative 1, a negative 2, or both negatives to get to a final value of 1? A negative 1. It's 2 minus 1. 2 minus 1 is 1. Those are my two numbers. So how does this finally factor? I would call this 2x minus 3. That's the part we did not touch. Now we factored this. So it'll be 2 parentheses. X method creates 2 parentheses. You split your A terms power. X and a x. And now I fill in these two numbers. A plus 2 and a minus 1. Question for you. That right there is the factored form. How many zeros would that have? 3 zeros. Very good. Why 3 zeros? 3 starts with an F. 3 factors. The factors would be, we already solved this one. That's not going to be a positive 3. It's going to be positive 3 halves. Now, why is it 3 halves? Because this becomes a plus 3, but what do I do with the 2 that's multiplying? Divide it. So it becomes plus 3 divided by 2 is a 0. What is this one 0? Negative 2, and this one? Positive 1. If we had more time, I'd show you the graph. This would work. That would turn out to be true. So that's how you can factor doing synthetic. I'm going to do this again, just because I know there's a lot to it. I'm going to copy this so we can see these as we go through again. Okay, so let's try it one more time here. I'm going to go ahead and paste the steps in. All right, y'all tell me. It says here, solve the divisor for x. What is my divisor on this problem? Okay, so we need to solve this. So we'll say 3x minus 4 equals 0. Solving it, you set it equal to 0 like that. What would happen to the negative 4? Becomes a positive 4. So I'll draw an arrow. So now I have 3x equals positive 4. Very good. And now there's one more step. What do I do with the 3 that's currently multiplying? Divide it. So what does x actually equal? Now what that means is if we get a remainder of 0, that is a 0. 4/3 would be where it crosses the x-axis. So now we do this, write out the coefficients. So I actually put the 4/3 in what I call upside down division position. And then I write out my coefficients. My coefficients are 6 x cubes, a positive 1 x squared, a negative 117 x, and then a plus 140, positive 140. Am I going too fast or y'all with me? Okay, it says drop the first term and follow mama. So 6 drops. And now we do mama. What does mama stand for? Okay, so we multiply first. So multiply the numerator. What's 4 times 6? 24, good. Then you divide by 3. 8. Since it's a positive 8 and we're adding, I'm going to put plus 8. Because we just multiply, now we add. What's 1 plus 8? 9. Okay, so we take 9. And now we're back to multiplying. 4 times 9. 36. Divide that by 3. 12. Good. We are adding, so I'll put a plus. Negative 117 plus 12. 105. Now this one's going to be a real big number. Anybody know what 4 times 105? What is 4 times 100? What's 4 times 5? So what's 400 plus 20? 420. And 420 divided by 3. 3 goes into the 4 once with the remainder 1. So the 1 carries over in front of the 2. 3 goes into 12 how many times? 4. Then you add the 0. Oh, this is a negative. Sorry, this is a negative 105. So what does that mean? This 140 needs to be a negative. Now, what's positive 140 minus 140? What's it mean if you get a 0 here at the end? That's a remainder. And if you have a remainder of 0, I'm going to do 3 triangles for it, therefore. That means since 0 is our remainder, x equals 4/3 is a 0. And 3x minus 4 is a, what's the vocabulary term? Is a factor. Very good. So we've done 3 steps. This was step 1. This was step 2. This was step 3. Now we do step 4. It says if the divisor is a fraction. Is this a fraction? You divide the quotient. The quotient means the answer to division by the denominator. So everything gets divided by 3. Remember, this was an x cubed. When it drops, it loses a power. This was an x squared, so now it's just an x. This was an x, so it's now nothing. So what do we get for our answer? We're going to have 3x minus 4. That was what we divided out. Over here, what's 6 divided by 3? So it's 2x squared. This is a positive. 9 divided by 3 is 3x. This is a negative. 3 goes into 10 how many times? 3 with a remainder of 1. So 1 goes right there. 3 goes into 15 how many times? 5. Now are we done there? What can I do with this part? We can do X method. So A times C over B. A, B, C. What's 2 times negative 35? Very good, negative 70. And okay, this is a bigger number. We probably need to write out the factors until we get something that could add or subtract to be 3. What can multiply to give you 70? Ignore the negative till the end. 1 times 70, 2 times 35, that's how we got to 70. 3 does not go in, 4 does not go in, 5 does. 14 times. 6 does not go in, 7 does. 10 times. 8 does not go in, 9 does not go in. Now we're at 10. We already wrote down 10, so we got them all. That's our list. Which one could add or subtract to give you a 3? 7 and 10. Okay, to get a 3, I want to put the 10 first. How do I get to, because it makes more sense in my brain to do it this way. How do I get to a 3? Is it a -10, a -7, or negative? And that's why I put the 10 first, because it makes more sense in my brain. So that means when you write out your answers, we have 3x minus 4. Oh, this is the first time I have to show you this trick. There's one more thing. We split the a term's power. So it was a squared. It now becomes a 2x and a 2x. Why? Because it has this a. You just split the power. You don't split the coefficient. You put in these numbers, plus 10 and minus 7. Now, right now, I have something incorrect. Now, I wrote it out all right, but something's incorrect. You multiplied this back out. When you multiply the 2x times the 2x, are we going to get 2x squared when you multiply 2x times the 2x? Now, you get 4x squared. So whenever you write it out like this, you split the power, you don't split the coefficient, but you'll make a math error. To make up for it, one of these two parentheses can be simplified by a factor of 2. You see how there's only one a value of 2, but I wrote it twice. It means one of them has to be simplified out. Which number can get divided by 2? 10. So here's how I'll do it in the future, is when we get to this step, before we rewrite it, I'll say, okay, we have an a that's not 1. That means we'll have a number written extra time. One of these two can simplify. Which one can be simplified by 2? 10 or -7? And you would say 10. And so I'll write it in right there. And so this one is the value gets divided by 2. So the true answer, as long as you put the divided by 2, it's accurate now. The true answer will look like this. It'll be 3x minus 4. The number that can get simplified only gets a value of 1 power. I mean, it gets 1x rather than 2x plus 5. And then 2x minus 7. That right there is the true answer. If you're going, wait, why did I have to do that? Because we wrote out an a twice and we had to cancel it out to make it mathematically accurate. That's how it becomes accurate. You're like, well, why was the number 10 here? Because, do a quick math. The way we get this 10 is because it has to be 5 times, what's 5 times 2? That's going to create the 10. If I didn't simplify it, it would have been 10 times 2. What's 10 times 2? 20, and it wouldn't have worked right. Because that 2 had to be in there, I had to divide that number to make sure it mathematically works. You could do all the math. You could write all this out and do all kinds of multiplying, and you'll see you'll get that number. You'll get 140 if you take -4 times 5. That's -20 times -7 gives you positive 140. You'll see that the math actually works. All right. You've seen synthetic now. What is this telling us? Well, if I did not tell you what factors to use, this is telling you you could predict what to use. You can look at this later. It's called the PQ test. You can read all the way over this. I'm going to show you here. If you did not know what could possibly divide it, there's this test to figure out the numbers. We're going to have a calculator that we can use all throughout the year, but I'm going to do this one time here because you do need to know the formula. According to the PQ test, the PQ test. Am I doing that right? PQ test. Yes. P and P. Whoops, that's supposed to be a Q. P and Q. Now, what's the PQ test telling you? It says this. If you write out what value is P, P is your very last term. P is the very last term. Q is the coefficient in the very first term. What's the coefficient here? 1. What this is saying is if you find all the factors of 4 and divide them by all the possible factors of 1, you'll have all the possible places, rational places, that means like something that can be written like a fraction, that you could have a 0. In this case, what are the numbers that can multiply to give you 4? Stay with me, Kyron. What are all the numbers, kind of like an X method here. What are all the possible numbers that could ever give you a 4? 1 times 4, 2 times 2. We could also have a -1 times a -4. So I'm going to do plus or minus 4. And then, like you said, a +2 times a +2 and a -2 times a -2. You don't have to write any number twice. So just write it out like that. Now, what are the only numbers that could multiply to give you 1? 1 times 1. So +1 times +1 and -1 times -1. Those are the only possible numbers. Now what we do is we go one by one and just divide these out. I'm going to write this. I'm going to write from smallest number to largest number. So what would be a 1 divided by 1? What if it was a -1 divided by +1? You're only going to either get a +1 or a -1. So our answer will be plus or minus 1. Now I'm going to skip the 4 for a moment because I'm going to go smallest to largest. Now you do it with 2 divided by 1. What's 2 divided by 1? 2. Well, what if I had a negative? So it's either +2 or -2. And now here, what about the last number? 4 divided by 1, what are we going to get there? 4 and -4. These are the only places, this equation, if it ends with the 4 and it starts with the 1x cubed, these are the only locations the graph could ever hit the x-axis. It could not hit the x-axis at the value of a 9. It could not hit the x-axis at +9. It could not hit at -9. Why do I know that? Because this is a 4. It's not possible. If this is a 1 and this is a 4, it could not hit at 9. The only locations it can hit the x-axis are +1, +2, +4. That's the only possible places. Okay? Only possible places. The only possible places that could hit the x-axis with those two, the first term and the last term. The leading term and the last term. Okay, let's do it again, just so you can see it again one more time. What would we call our P? What is the very last term in this problem?
15.
What is our Q, the very first coefficient? 2. The only places. Okay, if P is 15, let me write this out. And Q is 2. The only possibilities this graph could ever hit the x-axis, no matter how much you change the middle two terms, no matter what they are, the only two places they could hit. Let's see. What are the factors of 15? What can multiply to give you 15?
1 times 15.
Positive negative 1 times positive negative 15. What else?
3 times
Positive negative 3 times a positive and a negative 5. Again, it could be a negative times a negative or a positive times a positive. That's them. You got them, all of them. What are the only numbers that can multiply to give you 2? 1 times 2 and
2 times 1.
2 times 1 is the same thing. Or a -1 times a -2. Those are the only ones. So they're always going to be plus or minus on this. The rational zeros, possible rational zeros, it's always going to be a plus negative. Now all we do is we simplify. We divide them out. I'm going to go from smallest number to largest number. Make sense? And I'll divide by 1 first. What's 1 divided by 1? Next smallest is a 3. What's 3 divided by 1?
3.
Okay. And again, they're always plus or minus. What's the next smallest? It looks like a 5. What's 5 divided by 1?
5.
And then finally, 15 divided by 1 is... Okay, now we do this again, but what do I do different this time? Everything gets divided by 2. What's 1 divided by 2? Just 1/2. What number comes next? 3 divided by 2. What's 3 divided by 2?
3/2.
3/2. 5 divided by 2?
2.
Finally, last one. 15 divided by 2? That does not simplify, does it? So we just leave it as 15 over 2. That's the last one. That's the only places this graph could ever hit the x-axis, no matter how you change the -5 and the -28. That's what it's saying. The only possible places that could hit the x-axis are there. Now, you've seen the whole lesson, so I have three DOLs for you. I have one where I want you to do a synthetic. I have one where I want you to get the factors or the roots by graphing. So do synthetic, graphing, and then here you could do your rational zeros theorem. That's what we just did. That's the P over Q. Simplify that way. After that, you can go check out these DOLs.